Tommy plays a game in which two fair dice are rolled. If the total showing on the two dice is composite, he loses $1. If it is prime, he wins $2. To the nearest cent, what is the expected win or loss per play? Circle win or loss and state the amount. So the first thing I want to do is start off and figure out what is the probability of getting prime and what is the probability of getting composite. So we know the total outcome, there could be 36 total possibilities with two dice being rolled. 6 for the first dice times 6 for the second dice for a total of 36. So we know that to be true. So now we need to figure out for prime and composite how many for each of those. So for prime, okay, the numbers between 2 through 12 that could be rolled, prime is going to be the numbers 2, 3, 5, 7, and 11. Okay, it's going to be easier to work with prime first because there are fewer prime numbers than there are composite numbers. So the prime numbers, 2, 3, 5, 7, 11, I can get those by either getting a 1 and a 1 for a total of 2. To get 3, it could be 1 and 2 or 2 and 1. For 5, it could be 1, 4, it could be 4, 1, 2, 3, or 3, 2 listed here. 7 could be any of these. 11 could be any of these. So the total possible I could get for prime numbers would be, if I count those all up, it's going to be 15 total. Okay, so my favorable for prime is going to be 15 over the total of the two dice being rolled. Favorable over total is going to be 15 over 36. Okay, that is a probability of rolling a prime number. Now, if there are 15 prime numbers, or 15 ways to get a prime number, then there's going to be 21 remaining ways to get composite. So the probability of getting composite is going to be 21 over 36 right here. So we have what's called an expected value when we work with probability. And to find this expected value, we need to use the probabilities that we found, then multiply it by whatever we'll be receiving for each of those. So for example, in this case, for the prime numbers, 15 over 36, he's going to win $2 as stated in the problem. So the amount that he can win from rolling a prime number times the probability is going to be the expected value of getting a prime number. Okay, but then we need to take into account the part with the composite number. So the composite, there's a 21 out of 36 chance of getting composite, and for each one of those he's losing $1. So it's going to be a -1 for each time that it's rolled. So -1 times the probability of getting composite. So my expected value, the total value, is going to be whatever this is equal to. Okay, so I'm going to get a total of 9 over 36 when I multiply and add together, which will be 1 over 4, which can be simplified as in cents as 25 cents or $0.25. So it's a positive number, meaning he's going to be winning money, and the amount is 25 cents. So what we just found is if he were to roll the dice towards infinity, keeps rolling forever and ever and ever, then over time he'll find that the average winnings is going to be 25 cents. So the average winnings per roll is going to be 25 cents if he keeps going forever and ever. And that is kind of what expected value means. If you want more information, Khan Academy does have a lot more in-depth with just kind of the ins and outs of how this works. So feel free to check that out if you're kind of confused with how expected value works.